Go. Hello everyone, myself Gopi. My roll number is 23BQ1A0411. My topic was orbit and classification of orbits. Introduction of orbit mechanism for the formulas of Earth orbit types LEO, MEO, GEO, GSO, HEO. Comparison studies representation. Now tell about orbits. An orbit is the path followed by an object under gravity around a large body. Centripetal force while velocity provides forward motion. Result continuous free fall around Earth instead of falling straight down. Now I discuss about the diagram of the orbits. This is the center of the Earth, and the center part of the line was the Moon, and Moon orbital is gravity taken. Now I discuss the force and motion. Gravitational force F equals to gm m by r square. Centripetal requirements equals to mv square by r. Equating both gives orbital speed P equals to V by g m by r. Now I tell about orbital diagram of the centripetal force. This is the middle of the centripetal force, Earth, and the orange gray is the satellite, and the satellite gives to gravitational force. This is the dotted lengths of the orbit. This will be goes to on the Earth of the centripetal force. Now I discussed about orbit period and energy. Time period T equals to 2 pi V R cube Gm. Total energy E equals to 1 by 2 mv square minus Gm m by R. E less than 0 bounded orbit E equals to 0 escape E greater than 0 hyperbolic. Now I discuss of the classification of shape. Circular orbit constant radius and speed E equals to 0, and elliptical orbit varying distance and speed 0 less than E less than 1. Parabolic orbit just escape E equals to 1. Hyperbolic orbit flyby by minus E greater than 1. Now I discuss about the orbit elements size and shape. They are the four types of the orbits sizes: semi-major axis, eccentricity, perigee, optic. Now I discuss of the semi-major axis, orbit size and time period. Eccentricity is the orbit shape. We discuss about electricity means E. Periods of closest point. Approach means farthest point of the orbit elements. We can derive these four types of the orbit element size and shape. Now I discuss about the orbit element orientation. These are the inclination, longitude of ascending node, argument of parabolic, true normally. These are the orbital elements of orientation. Now I discuss about the inclination, tilt of orbital plane, and longitude of ascending node, crossing point. Argument of parapaces is the direction of closest point. True anomaly means current position angle. Now I discuss of the diagram of the argument of parapaces true normally. This is the green line of the longitude ascending node, and the red line of the truly anomalous, and blue line of the argument pairage. And central of the node, longitude of ascending node is derives to reference direction, and the white line of the lane is the plane of reference, and green line of the inclination, and the center of the round of the diagram, this is the ascending node of the orbital plane. Now I discuss of the Kappas law. Planet move in elliptical orbits, equal areas in equal times, speed change, t square proportional to a cube. Bigger orbital takes longer. This follows from Newton's gravity. Now I discussed about orbit types overall. There are the orbitals are classified by altitude and purpose. LEO, MEO, GEO, GSO, HEO each survey different missions. Choose difference of on coverage, delay, constant, and lifetime. Now I discuss about they are the parts LEO, MEO, GEO, GSO, HEO. They are the some major parts of the Earth orbital. They can be clarified into first one LEO. LEO means lower Earth orbital. The altitude is 160 to 2000 kilometers speed, 7.8 kilometers to period 90 to 120 minutes. Lowest latency communication and high resolution imaging. Atmospheric drag present, shortest lifetime. used for Earth observation, remote sensing, and space station. The lower Earth of the orbital is altitude of the speed of light communication, high resolving image. Atmospheric is the shortest time of the drag present. Used for Earth observation, sensing space station, and these are the lower Earth orbitals in LEO. Now I discuss about the MEO. MEO means medium Earth orbital. Altitude is 2000 to 35,786 kilometers. Moderate speed and moderate delay. Wider coverage than LEO. Fewer satellite needs for global coverage. Main use navigation system, GPS and positioning. Now discuss about GEO. GEO means geostationary orbit. Altitude 35,786 kilometers exactly above equator. Period 24 hours. Matching Earth rotational appears fixed to ground. Observe very large coverage. 1 by 3 Earth. Used for TV broadcasting, telecom, weather satellites. Now I discuss our GSO. Period also equals 24 hours but may be inclined or elliptical. Satellite appears to move in small path. Includes geo a special case. Useful when time synchronization of is required. Used in some communication and tracking missions. Now I discuss about HEO, highly elliptical orbits. These are the optical orbits are highly elliptical orbits are stationary path of highly acceleration. These are the main parts of the HEO. Now I discuss about HEO as the highly stretched elliptical path with high eccentricity, long dwell time near approach for regional coverage, useful for high latitude or polar regions. Speed varies, fast near, very slow near approach, used for scientific studies and special communication. These are the HEO, GEO, ESO, and ready, one, two, three, start. I will discuss about these types of satellite orbits. This is the earth of the orbits. They are given for the LEO, MEO, HEO, GAO. These are the four of the satellite direction from the orbital to rotated of LEO, LEO to rotated to MEO, MEO rotated to HEO, HEO rotated to GEO, GEO rotated to GSO. These are the types of satellite orbitals. I discussed about the differences of the parameters. LEO, MEO, GEO, GSO, HEO. LEO means low Earth orbital, medium Earth orbital, MEO, GEO, geostationary Earth orbital, geosonic orbital, higher Earth orbital. Now discuss about low Earth orbital, 60 to 2000 kilometers, and circular. MEO means 2000 to 35,786 kilometers, and GEO 35 to 786 kilometers, GSO 35 786 kilometers, and HEO 500 to 40,000 kilometers. Now orbital shape, circular, 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 elliptical. I am describing inclination. LEO and any, MEO means any, GMO 0 degrees only, GSO means 0 to 90 degrees only, HEO means elliptical. I am discussed about the period of the parameters. 90 to 120 kilometers. MEO means 2 to 12 hours. GSO means 24 hours. GSO means 24 hours. And HEO means 12 to 24 hours. I'm discussed about the relative motion. LEO means move fast. MEO means move moderate. GEO means appears fixed. GSO means figures 8 drift. And HEO means slower near approach coverage area small. Leo means small, MEO means medium, GEO means very large 1 by 3 earth, and GSO means large, HEO means large over one region. Now I discuss about the satellite needed for global coverage area. 50 to 100, and MEO means 10 to 20, and GEO means 3, GSO means 3 to 4, HEO means 2 to 3. Latency delay 5 to 20 minutes, LEO and MEO means 5 to 50 to 150 meters, and GEO means 240 to 280 meters, and GSO means 240 to 280 meters. HEO means variable, and the path losses means LEO very low, MEO medium, GEO means high, GSO means high, HEO means variable. Transmitted power required. LEO means low, MEO means medium, GEO means high, GSO means high, HEO means medium. I discuss about the attendant size of the ground. LEO means small, MEO means medium, GEO means large, GSO means large, HEO means medium. Now I discuss about the upper affected high. LEO means high, MEO means medium, NEO means GEO means negligible, HGSO means effect of the parameters. LEO means high, MEO means medium, GEO means negligible, GSO means negligible, HEO means moderate. I discuss about the launch cost low. LEO means low, MEO means medium, GSO means high, GSO means high, HEO means high. I discuss about the parameters of the launch cost. LEO means low, MEO means medium, GEO means high, GSO means high, HEO means high. I discuss about the satellite lifetime. 5 to 7 hours, LEO means, MEO means 8 to 12 hours, uh, GSO means 15 to 20 hours, and GSO means 50 to 20 years, HEO means 15, 10 to 15 years. Power required of the parameters. LEO means yes, MEO means sometimes, GEO means no, yes, sometimes. I discuss about the ground tracking needed. LEO means yes, MEO means sometimes, and GEO sometimes. I discuss about the best for satellite perimeters. Means image to broadboard, and MEO means navigator, and GSO means TV and telecom. GSO means as GEO but inclement. HO means polar coverage area. They are the HU, LEO, MEO, GEO, GSO, HEO. They are the some examples of the LEO, International Space Station. MEO examples for GPS, GSO examples for Instat, GSO compared GST, examples for Monalia. These are the parameters of the LEO, MEO, GEO, GSO, HEO. Now I discuss example of summary. Orbits results for balance between gravity and motion, energy and orbit elements for describe motion, different altitude survey given purpose, LEO, MEO, GEO, GSO. These are LEO.